make sure that you review this caution in your text, and remember that you never divide an equation by any expression that contains a variable. For one reason, you will lose one of your solutions, and for another reason is that you don't really know whether that expression is equal to 0 or not. And remember, dividing by 0 is not allowed. So we talked about that in class. We also talked about how you have to be careful when you're grouping to preserve your signs. So in a problem like this where you have to factor by grouping, it's not a good idea just to shove some parentheses in there. You have to be very careful about the parentheses placement, especially if there are subtraction signs involved. So there's a subtraction sign there. So we found out that we had to write 2x minus 10, even though the 10 over here is a plus. Remember, if that minus sign is outside the parentheses, it's going to combine with that minus sign and give you a plus. But if you had a plus right there, it would combine with that minus sign and give you a minus, which isn't correct. So the main idea here was to be careful about where you place those parentheses and making sure that your signs are correct. So check your work when you do that step, and just go that way, or I'm sorry, go that way again, and just check to make sure that you've preserved all of your signs properly after you've done your grouping. We did equations that involve fractional expressions and found that the method is the LCD method. The lowest common denominator of the fractions in the equation is what you use as your multiplier to clear all the fractions out. And so I like to enclose my enclose the equation in parentheses and then write the LCD on both sides so that I don't forget to do it to both sides. So the LCD is x minus 1 times x plus 2 times 4. And so we see that as we work through this problem, in the first expression the x minus 1's are going to cancel out, and you end up with 4 times x plus 2 times 1, which I don't write. In the second expression, the x plus 2's are going to cancel out, and there's a plus right here, so I write a plus. Now the x plus 2's canceled out in the second expression, but I still have the x minus 1 and the 4 and this other one that I'm not going to write. Now I'm on the right-hand side. The only ones that cancel with each other are the two 4's, and that leaves me with 5 times x minus 1 times x plus 2. So multiply these two binomials first, and then multiply times 5 and get that right-hand side. And on the left-hand side, multiply these two expressions and combine similar terms and get what's on the left-hand side. When you're done with all that, you should have a quadratic equation that you can then solve. And just make sure that when you're done, that x doesn't equal either positive 1 or negative 2. We talked about that in class. Those expressions in the denominator tell you that x cannot equal 1 because that would make x minus 1 0. Can't have 0 in denominator. Also, x cannot equal negative 2 because that would also give a 0 in the denominator, which is not allowed. We looked at equations that are quadratic in form. They're types of quadratic equations, but not really quadratic. So we look at this one, and we see that we have this expression squared, and then here we have the same exact expression. So we use a change of variable. We substitute for that expression 1 over x plus 1. We're just going to write w. And so now what we have is w squared minus 2w minus 8 equals 0. This can be factored, and when you factor it, you'll end up with two factors, and then the solutions will be x equals, let me think, I think it's x equals 4, or w equals 4, and w equals negative 2. So then you take those values for w and substitute them into this relationship between w and x. So you substitute 4 where w is and find out what x is. That gives you a little fractional equation to solve. You substitute negative 2 for your second one where w is and get that second solution. So I'll let you finish those details on your own. We did that in class. Here we have a similar situation. We don't have a quadratic equation, but we do have the first term has degree that's double the second term here, and the third term is a constant. So this time we let w equal x squared, and then w squared is x to the 4th power. And so now we can substitute, this will be w squared minus, this will be 13w plus, the last term is still just 40, and that equals 0. Again, this is factorable. The factors are w minus 8 times w minus 5, and that gives us w equals 8 or w equals 5. And once again, you have to take those values for w, 8 and 5, one at a time, and substitute them into the equation that you wrote down that gives you the relationship between w and x. So 8 equals x squared. So x is plus or minus, don't forget, plus or minus the square root of 8, which can be simplified to 2 times the square root of 2. And do the same thing for w equals 5. I'll leave those details to you. This last one is, again, another one that's not quadratic, but it's quadratic in type, because we see that the expression here, x to the 4/3 power, is exactly double the exponent for x to the 2/3 power, because 2/3 is double 4/3. So here, if we let w equal x to the 2/3 power, then w squared is x to the 4/3 power, because x to the 2/3 squared is x to the 4/3. Remember, you multiply the exponents in this situation. This is multiply the exponents. If you multiply 2/3 times 2, you get 4/3. So now we substitute these values into our equation, so we recognize the quadratic. This first term becomes w squared. The second term becomes 5w. And then we have plus 6 equals 0. Again, this is factorable, so you can factor, and you'll find out that the factors are w minus 3, w minus 2. So you end up with w equals 3 or w equals 2. Those values have to be substituted into your equation, which is the relationship between w and x. And that equation is right here because you wrote it down. So first we'll substitute w equals 3. We get 3 equals x to the 2/3. And now to change that to x to the 1, we're going to raise this side to the 3/2 power, because that rule is multiply the exponent, so we have to do the same thing to the other side, raise 3 to the 3/2 power, and so now we get x equals 3 to the 3/2 power. You can verify for yourself, or I can show you, 3 to the 3/2 power is 3 to the 1 plus 1/2 power, and that's 3 to the first power times 3 to the 1/2 power, and 1/2 power means square root. So it's just another way of writing 3 times the square root of 3. 3 to the 3/2 power just means 3 times the square root of 3. You can do the same thing with the other solution, w equals 2. You substitute the value 2 into the equation. That's your relationship between w and x. So in this one, we're going to take 2 and substitute it in there for w. We get 2 equals x to the 2/3 power. Raise both sides to the 3/2. 2 to the 3/2 power equals x. Okay, when this problem about chartering a bus, now there's a sample problem in the textbook. I don't remember what page it's on, but it's really similar to this, so you might want to study that example problem. I think it's example 8. At any rate, this has to do with chartering a bus, and we know the cost for the trip is $900, and then at the last minute, 5 people in the group decide not to go, and so that's going to increase the transportation cost per person, and the cost per person will be increased by $2. So the question is, how many people originally intended to take the trip? So I'm going to let x equal the number originally. And what I mean by that is originally intending to take the trip. Okay, so I know that the trip was going to cost $900 for all of those people, and so that means that the cost per person originally is, I'm just going to put orig, is that $900 divided equally among the x people. So 900 divided by x is the cost per person originally. Well, what happens? When the 5 people drop out, we now have x minus 5 as the number of people, let's just say the number new instead of originally. Okay, so the new group has 5 fewer people, and so now the cost per person, because there are 5 fewer people, the cost per person is obtained by taking that $900 and dividing it equally among the x minus 5 people that we now have. So these are two expressions that tell us something about the cost. The first one is the original cost per person, and the second one is the new cost per person. We still don't have an equation, but we can get an equation now because we read the problem again and see that we know that when the 5 people dropped out, it raised the transportation cost, and by that it means it raised the original transportation cost per person by $2. Well, the original transportation cost was 900 over x, and so once the 5 people dropped out, that number is raised by $2. So that's also the cost per person new. The cost per person after the 5 people dropped out can also be obtained by taking the original cost per person and adding $2 for each person. And so now we see we have two expressions for the same thing. We have two expressions for the cost per person new. The first expression for cost per person new is 900 over x minus 5. And the other expression for the cost per person new is 900 over x plus 2. Well, those two things must be equal, and so that's our equation. The cost per person, no matter which way you figure it out, has to be the same. So now this equation is a fractional equation. I showed you how to do these in an earlier part of this video. It's a fractional equation. So you're going to use the LCD method to solve it. And once you solve it, you'll find out what the new cost per person is. And just so you can check your answer to make sure it's right, oh, actually, I didn't work this problem out all the way, so I don't really know what the answer is. So maybe you'll just have to tell me. Let's go to the next problem. Deals with the construction cost of building a road between two towns. And so what's happening is that we have a town called Foxton that lies 10 miles north of an abandoned east-west road that runs through another town called Grimley, as shown in the figure. So here's Foxton. Here's Foxton. And Foxton is 10 miles north of the abandoned road that runs through Grimley. And what we want to do is build a new road, but we want to use part of the abandoned road. And the question is, how can we keep the cost at exactly $6.8 million if we know that restoring the old road costs $100,000 per mile and building the new road costs $200,000 per mile? The question is, where should we make that turn? You know, where should we make that turn off of the new road, and what part of the abandoned road should we use? And then there's a related question, would it cost less than this amount to build a new road connecting the towns directly? So a new road connecting the towns directly would just go all the way across a new road. So the question, we'll answer that question later. But for now, we want to find out how to, first of all, quantify our variable. Well, we want to know how much of the abandoned road should be used. So let's let x equal the miles used on the abandoned road. Miles used of abandoned road. Okay, once we know that, we'll have the answer to our question. X is the number of miles used of the abandoned road. Now, this is all related to the cost of building these roads. So let's think about what the cost of building these roads would be. First of all, we know that restoring the old road is $100,000 per mile. So on our figure, the miles of the abandoned road would be right there. That's X miles. Okay, so we know that that's going to cost us, because that's the old road and we have to store it. The cost of restoring the abandoned road is $100,000 times X. So that's pretty good. Now we need to figure out the cost of using the new road. Well, the new road has to be constructed right here, and we see that that is the hypotenuse of this right triangle. You see that right triangle right there? We have this right angle right here. And so that means that we need to know the length of that hypotenuse. And by the Pythagorean theorem, it's equal to the square root of that side squared, which is 10 miles, so 10 squared, plus that side squared. Well, that side is 40 minus the x that we have over here. The total 40 minus the x here tells us this length. And so that means that by the Pythagorean theorem, we know that the hypotenuse is equal to the square root of 10 squared plus 40 minus x squared. And that's by the Pythagorean theorem. Okay, so you can work out this 10 squared plus 40 minus x squared, and if you do that, you should end up with, let me erase a little bit of this so I can do it a little better. If you work out that 10 squared plus 40 minus x squared, you should end up with, this line is not good there, but you should end up with x squared minus 80x plus 1,700. So make sure you can do that. That's all inside the square root. X squared minus 80x plus 1,700. And so that means the cost of the new road, cost of building the new road, is going to be the length of the new road, which is the square root of x squared minus 80x plus 1,700 times the number of miles of the new road, times the cost per mile for the new road. And that is $200,000, so times 200,000. Well, these two costs, the cost of restoring the old road added to the cost of building the new road, has to equal the total cost of $6.8 million, and that's our equation. So let's write that equation down. The cost of restoring is 100,000 times x. The cost of the new road is 200,000 times the square root of x squared minus 80x plus 1,700, and that has to equal the total cost, which is 6.8 million, which is $6,800,000. That's the equation that we now have to solve. The equation is 100,000x plus 200,000 times that square root is equal to 6,800,000. Well, the first thing we can do is divide everything by 100,000 to get rid of some of these big giant numbers. So let's go ahead and do that. If we divide everything by 100,000, then the first term becomes x. The second term becomes 2 times that square root of x squared minus 80x plus 1,700. So that's much more simplified. And on the right-hand side, if we divide by 100,000, we should get 68. 68. Okay, the next step is to isolate this radical on one side of the equation. We're going to prepare to solve this equation. So we have to do that by isolating this radical expression. This expression should be on one side. So we're going to shift this x over to the other side. We end up with 2 times the square root of x squared minus 80x plus 1,700, it's all inside the square root, equals 68 minus x. And now to get rid of that square root sign, we square both sides, and we square both sides by just imagining that we have parentheses here, and we're going to square, and we have parentheses here, and we're going to square. So now you have to be careful, because when you square two factors, each factor gets squared, so you've got to square the 2. When you square the 2, you get 4, and when you square something that's inside of a square root, it just removes the square root symbol, and so you get this. And I'm not going to square the other side. I'm going to leave some of that work for you to do. So what I want you to do is I want you to go ahead and multiply out the right-hand side, multiply that all out, multiply out the left-hand side, collect all your terms together, put the equation in standard form for a quadratic, practice doing that because it's a skill that you need to practice. So practice that skill. When you're done, you should get this equation. 3x squared minus 184x plus 2,176 equals 0. If you just take my word for it, then you will have missed out on all the practice. You need to practice this and get that equation. That's the hard part. Now, once you have that equation, since the numbers are so big, I would recommend that you just use the quadratic formula to solve this equation. So go ahead and use the quadratic formula to solve the equation, and when you're done, you should get two solutions. And I want you to think about which solution you have to discard because it doesn't make sense for this problem. You should end up with just one solution because the other solution that you get won't make sense. And you'll see what I mean if you actually work it out. So one solution only is what you should get.